students. I am your chemistry mentor Supriya, and the topic for today is delta G naught and equilibrium constant. Again, a topic from electrochemistry. So, we have two important formulae related to delta G naught. So, one relates delta G naught and equilibrium constant K, that is delta G naught equal to minus 2.303 RT log K, and another relating delta G naught and E naught of cell. So delta G naught equal to minus NF E naught cell. So you know here N is number of moles of electrons and F is Faraday's constant. And this is from Nernst equation. In the last video, we had seen Nernst equation. So there we had written E naught cell minus 0.059 by N log of product by reactant. So you know that the ratio of concentration of product by concentration of reactants is called reaction quotient Q. Okay, and at equilibrium we write the same thing as equilibrium constant K. Okay, so at equilibrium what happens? E cell will become 0 and Q becomes equal to K. So if you substitute that, you will get E naught cell equal to 0.059 by N log K. So we can rearrange and write log K equal to N E naught cell divided by 0.059. So this equation is helpful when equilibrium constant is asked. So let us see few questions related to this. So first one, if the E naught cell for a given reaction has a negative value, okay, so E naught of cell is negative, they said, then which of the following gives the correct relationship between delta G naught and K? Okay, means what is the value of delta G naught and K here? See, when E naught of cell becomes negative, see this equation. If this E naught of cell is negative, then negative into negative becomes positive. So delta G naught becomes positive here, right? So delta G naught will be greater than 0. So eliminate these two options. Now we need to check for the value of K. So we need to take this first equation. See, now we got that delta G naught is positive, right? So if delta G naught is positive, here this side you need to get a positive value. Already we have a negative sign. So if K becomes less than 1, then log K will be negative. So negative into negative will be positive. Okay, so the K value should be less than 1 here. If K value becomes greater than 1, log K will be positive and you will get delta G naught negative. Okay, but we already have delta G naught positive, so the value of K should be less than 1. That means this is the right option. Delta G naught is greater than 0, K is less than 1. Okay. Yeah, let us take one more example. Okay, so here the standard EMF of a galvanic cell involving 2 moles of electrons, means here N value is given, N value is 2. In its redox reaction is 0.59 volt. E naught of cell is given. The equilibrium constant for the redox reaction is. So here we need to calculate the value of K. So log K is equal to N E naught of cell divided by 0.059. Okay. So now let us substitute the values. N is 2 here. E naught of cell is 0.59 divided by you have 0.059. So if you shift this decimal here, it becomes 0.59 into 10 power minus 1. Right. So you can cancel 0.59 and 0.59. So I'll write it here. You have like this. 0.59 into 10 power minus 1. So cancel this. When 10 power minus 1 goes up, it becomes 10 power plus 1. So 2 into 10 becomes 20. So log k equal to 20. That means k equal to anti-log of 20. That is nothing but 10 power 20. Okay, always anti-log is 10 to the power, because here when I write log k, here the base is 10. So if I write something like log k to the base 10 equal to b, then k becomes equal to 10 power b, like this. So here k is equal to 10 power 20. So this is the right answer. So these are some questions related to delta G naught and equilibrium constant. That's all for today. If you found this helpful, please like, share and hit the subscribe button. Thank you so much.